Hello friends, this video is about quality protein maize. Let me give a brief introduction about maize. The botanical name is maize, family Poaceae, with diploid chromosome number 20. The center of origin is Central America or Mexico. The mode of pollination is cross-pollination and expected outcrossing is 95%. The probable progenitor of maize is teosinte. India is the sixth largest producer of maize in the world, contributing 2% of the global production. In India, maize is the third most important crop after rice and wheat and account for 9% of the total food grain production in the country. Major growing states are Karnataka and Andhra Pradesh. There are many countries across the world which are suffering from protein energy malnutrition. The major causes are kwashiorkor, marasmus, and other defects like eyesight, then hidden hunger, and so many multiple disorders are caused due to protein deficiency or hidden hunger. One of the approach to address this issue is quality protein maize in order to increase the lysine and tryptophan content in the maize kernels. That is nothing but to improve the protein quality. Quality protein maize is an improved variety of maize which contains higher amount of lysine and tryptophan with low amount of leucine and isoleucine in the endosperm than those contained in normal maize. The low lysine and tryptophan are the two essential amino acids. The major seed protein 60% and lysine level is about 2% but 4% is recommended by FAO. The need of improvement of nutrition is for human and animal quality protein maize, and this also has a major problem of low availability of niacin, and that leads to nutritionally limited crop as maize is deficient in many of the nutrients like the importance of deficiency of lysine and tryptophan in maize was made Osborne and Mendel to discover the mutants for this particular character, and that was discovered during 1914. Two scientists, Merz and Nelson from Purdue University, rediscovered a recessive mutant called OPAC2 in 1964. Coming to nutritional superiority of QPM, the lysine content in the normal maize is 1.3 grams per 100 gram of endosperm protein, whereas O2 is 3.3 to 4 grams per 100 gram of endosperm protein. QPM protein contains 55% more tryptophan, 30% more lysine, 38% less leucine than that of the normal maize. The leucine and isoleucine content are the lead to adverse effect on lysine content. When we have to increase the lysine content, automatically the leucine and isoleucine content has to be decreased. Biological value of normal maize is 45% and O2 is 80%. The aim of improving nutrition in QPM is with the comparison of cultivated or consumable rice, where rice is having up to 4% or 4 gram per 100 gram of endosperm protein of lysine. Protein intake utilization of common maize is 37% and O2 maize protein is 74%. Maize required for nitrogen equilibrium per kg of body weight in normal maize is 24 gram and QPM is 8 gram. Other nutritional benefits of QPM: higher tryptophan and lower leucine isoleucine content, higher calcium and carbohydrate and keratin, high niacin. This is a picture showing wild type and OPAC2 mutant of maize endosperm. The color differentiation as well as different character were found for the morphological markers. The lysine and tryptophan content of normal and QPM were compared here. The protein content in both say common maize and QPM are more than 8%, whereas lysine is 1.6 to 2.6 with a mean of 2 in common maize, and in QPM it is 4. Tryptophan in protein is 0.4 and in QPM it is 0.8. One cannot differentiate between QPM and common maize just by looking at the plant, ears or grain unless biochemical analysis is done to determine lysine and tryptophan content. The total quantity of protein in both QPM and common maize is same. Only the quantity or percent of the two essential amino acids in protein is greater for QPM than the common maize. Quality aspects of maize. The normal maize contains 39% quality as that of milk, whereas opaque maize has 90% of quality. That means it is suitable as a baby food as well as for the adult people. Early efforts and experiences in using O2 cultivars. Initiation of breeding program to develop inbred lines by using populations with endosperm quality mutants, mainly O2. In the initial stage, both O2 and FL-Flori2 genes were usually used singly or in combination with each other. In the later stages, some undesirable effects of Flori2 mutant were discovered. Its use slowed down and was discontinued. After decades, the major emphasis in most breeding programs was on conversion of normal genotype to O2 mutant versions. This was possible by the recurrent selection and other selection techniques incorporated in order to improve the O2 version of quality protein maize. Coming to the information about opaque 2 gene. A natural spontaneous maize mutant with soft and opaque grain was found in maize fields in USA during 1920s, which was later named as opaque 2 maize by Singleton. The mutant was passed on to Merge at Purdue University, USA, who in turn reported that O2 homozygous maize contained substantially higher lysine, that is more than 69% of normal maize in the grain endosperm compared to normal. The increase in lysine content doubled the biological value of opaque 2 maize protein, and this increase in protein quantity is due to increase in the ratio of non-zine to zine protein. That means zine protein is responsible for decreasing the content of lysine and tryptophan. The lysine is also adversely affected by the quantity of leucine and isoleucine in zine proteins. This is most abundant protein in the grain endosperm are in zine and particularly alpha zine, which are poor in lysine and tryptophan. The homozygous O2 mutant causes a decrease in the production of alpha zine fraction of endosperm protein and a corresponding increase in the proportion of non-zine proteins that naturally contain higher level of lysine and tryptophan. Therefore, in a given quantity of protein from O2 maize, that is in recessive form, the proportion of non-zine is higher, which predisposes O2 maize to have higher lysine and tryptophan. The other mutants of quality protein maize, one is opaque 2 that was discovered by Merz, Bates and Nelson. I can say it was rediscovered by Merz, Bates and Nelson in 1964. Flori2, this was discovered by Nelson, Merz and Bates in 1965. Opaque 6 by McVitter in 1971. Opaque 7 by Ma and Nelson in 1975. Flori 3 by Mlama and Nelson in 1975. Early efforts and experiences using O2 cultivar. This was utilized in breeding program, and that showed pleiotropic effect of the gene O2 that resulted in soft endosperm, damaged kernel and inferior food processing, and that was also susceptible to pest and fungal diseases and reduced yield. Simple recessive inheritance of O2 gene in plants. First, the capital O2O2, that is a original or wild form of O2 gene, is crossed to the mutant form of homozygous recessive O2 that gave F1 in heterozygous form, and by selfing that in F2 it gave 1/4 of dominant, half heterozygous and 1/4 recessive O2, and this 1/4 recessive O2 was the actual version of O2, and that helped in the improvement of maize kernel characters as well as lysine and tryptophan content. Genetic system and their role in enhancing the level of QPM or the lysine and tryptophan content. Development of QPM involve three genetic systems. One is recessive homozygous allele of O2 gene, modifiers for kernel hardness, and amino acid modifiers. The two things, that is modifier gene utilization and recurrent selection utilization, made the improvement in O2 version of QPM. The first one is recessive homozygous allele of O2 gene. Enzyme that is associated with free lysine degradation. Reduction in this enzyme lead to corresponding increase in free lysine in the endosperm. Genes and trigger increase in the level of lysine and tryptophan. Modifiers for kernel hardness. Increased level of gamma gene is likely to contribute to the recovery of hard endosperm. O2 modified grains have double the amount of gamma gene in the endosperm compared to O2 mutant. Two genes responsible for the grain hardiness mapped to the long arm of chromosome 7, and one of them is located near the gamma gene is GZR1. The amino acid modifiers, the third type, it also affects the relative level of lysine and tryptophan content in grain endosperm. Three genes associated with lysine level have been mapped to locate the chromosome 2, 4 and 7. Apart from this, several major O2 modifiers QTLs are located on chromosome 1, 7 and 9 have been recently mapped. This is a picture showing gradual increase in proportion of soft to hard endosperm, and the second picture shows special expression of O2 under different genetic backgrounds. Coming to development of QPM genotypes, that is through conventional breeding, and second one is marker assisted selection. Nowadays the QPM genotypes were also improved through the transgenic approaches, but because the transgenic food crops are not accepted in India, this concept is declined here. Coming to conventional breeding, development of acceptable QPM line by combining the nutritional advantage of O2 mutants with the O2 modifiers. During the 1980s, CIMMYT took initiative to convert a number of non-QPM genotypes to QPM genotypes. They followed a modified backcrossing cum recurrent selection. During the conversion process, they also emphasized grain yield, kernel modification, reduced ear rot incidence and other agronomic traits. In a short span of 5 to 6 years, CIMMYT could convert many normal germplasm into QPM, which were as good as their non-QPM counterparts for grain yield and other agronomic traits. The second approach is development of QPM hybrids through marker-assisted selection. In order to shorten the period of requirement for development of QPM hybrid through conventional method of backcrossing recurrent selection, the marker-assisted selection is used. Few molecular markers were already known within the O2 gene, and these markers were capable of detecting the O2 genes even in heterozygous state. To convert normal maize into QPM, a promising hybrid, that is Vivek maize hybrid 9, developed by Vivekananda Parvatiya Krishi Anusandhana Sansthan Almora, was selected for converting into QPM. This is a picture how they converted. For converting normal maize into QPM, first CML 180 into CM 212. CML 180 is a donor inbred line and 212 is recipient O2 gene. That gave VQL1 where 92% recovery was found or 92% O2 gene were reported. In the other cross, CML 170 into CM 145. Here CML 170 is a donor inbred line and 145 is recipient. That yielded VQL 2 and the recovery percentage was 94.44. This is a double cross hybrid. By again crossing the VQL1 and VQL2, Vivek QPM9 was obtained. This is O2 quantitative determination using SSR marker. The markers used were Phi57, Phi112 and UMC 1066. For any trait to identify, there is a rule. It is not a strict rule, but if it is there, it will be better that the markers flanking the a particular gene of interest and one marker located within the gene of interest will give a better result than the more distance markers. After developing the Vivek QPM9, the lysine, tryptophan and protein contents were determined and subjected to biochemical analysis. The hybrid was released for commercial cultivation in Himalayan states, Andhra Pradesh, Tamil Nadu, Karnataka and Maharashtra by Central Seed Subcommittee on Crop Standard and Notification in the year 2000. Here in this picture you can see at phenotypic level we can't differentiate the normal and QPM version. For countries like India, with diverse agroclimatic and soil conditions, there is a need to develop number of QPM hybrids for different maturity groups like early, medium and late. Major constraints in adoption of QPM hybrids in these areas are non-availability of hybrid seeds and lack of incentives like premium price of QPM over normal maize grains. There is also a need to create awareness among the consumers and industry for its use in food and feed. We are developing linkage between seed producers, farmers and industry to bring about much needed synergy in development and utilization of QPM that will help in reducing the protein. These strategies are recommended by CIMMYT Asia. The major constraint in QPM adaptation and development and widespread of QPM in India is there are very poor inbreds which are developed for QPM purpose, and the consumer acceptance, as we know that the consumed form of maize is always in white form, but the QPMs which we are developing in India are of yellow color. So the color also matters than inbred lines and the coming forwardness by the industrial people. Like in northern India, there are less industries which are located in order to improve the maize cultivation as well as to bring the major area into maize cultivation. So if we overcome these constraints, there is a large scope for QPM improvement. In 1970, India is one of the first few countries to focus on O2 maize and released 3 O2 composites like Shakti, Ratan and Proteina. In 1997, modified Super O2 composite Shakti 1 was released. That was a 3-way cross hybrid. Later, India released 8 QPM hybrids, 7 of which were developed from QPM inbreds of CIMMYT as parental lines and are the full season maturity. Those are HQPM1, HQPM5, HQPM7 and Vivek QPM9. Breakthrough achievement in development of miracle maize. Coming to the animal nutrition, effect of QPM on animal nutrition, there were several researches conducted and one of the report is here. Pigs raised on high lysine and tryptophan maize grain gained weight at roughly twice the rate of animals fed solely on normal maize with no additional protein supplement. In the picture, you can see a pig fed with QPM and a pig fed with normal. The size of pig increased twice as that of the normal maize, as equal quantity of high lysine maize substituted for normal maize in pig feeds can maintain the amino acid balance and decrease the use of synthetic lysine. Smallholder farmers who typically cannot afford balanced feeds and commercial farmers find this extremely remunerative. Coming to human nutrition, according to one report in Ghana, children fed with high lysine and tryptophan maize had fewer sick days and a better chance of escaping death due to diarrhea and other infections than those fed with normal maize porridge, reducing stunting in children weaned on high lysine tryptophan maize as compared to those weaned on normal maize porridge. Better growth enhancing capabilities in children consuming high lysine and tryptophan maize compared to those fed normal maize porridge. The agronomic practices or recommended cultivation practices for maintaining the QPM varieties, production and maintenance do not differ from that of the common maize. The only additional requirement is perform tryptophan and protein analysis to ensure the required minimum standards. That means the biochemical analysis is sufficient in order to differentiate between normal and QPM maize. Key issues in QPM grain contamination in farmers' field. The first issue is pollination of a QPM cultivar with common maize pollen result in non-QPM grain production. Hybrids or QPM's contamination in farmers' field is conditions like wind direction, distance and number of surrounding farms planted with common maize varieties. Contamination of QPM grain from adjacent maize fields can be reduced by, that is a remedy for contamination. Here, planting relatively larger plots to reduce the border area, planting square plots to reduce the length of borders, planting QPM plots upwind from normal maize plots or planting other crops. Harvesting border area less than 5 meters separately from the whole QPM plot and treating the grains as common maize grains. The advantage of open pollinated variety seed is used in the farmer's field as QPM version instead of using hybrid maize is to save part of the harvested grain for planting in the next season, but only for about 3 generations. As it is a common maize, OPVs of QPM also reused for about 3 generations. One question is, how should farmers select and save seeds from his or her own QPM open pollinated variety kind of grain? For this, farmer has to do select the OPV seed from subplot located in the middle of the fields of QPM, then select 200 to 300 ears for saving as seed for the next planting. Shell the selected ears, mix the seeds thoroughly, then purchase fresh seed OPV seeds from seed producers after using own seeds for not more than 3 years or 3 times. That means continuous use of open pollinated varieties of QPM will lead to contamination, and that will result in conversion of QPM into non-QPM lines. Coming to some of the agronomic practices, here the spacing and planting density, seed rate is 25 to 30 kg per hectare. Plots should be planted with either one extra seed per hole or per alternative hole to compensate possible losses in germination due to poor seed quality. Spacing between rows and between plants are 75 into 30 cm, one seed per hill, which will produce 44,444 plants per hectare. For early maturing varieties, recommended spacing of 75 into 25 cm gives 53,333 plants per hectare. For the extra early maturing varieties like Melcasa 1Q, it was cultivated in other countries like Mexico. Recommended spacing is 7, that is 5 centimeter into 20 centimeter. Conditions to achieve the optimum plant population on farmer's field are: the seed must be of high quality with high germination percentage, at least 85% germination as compared to 90% germination recommended for other varieties or hybrids of maize. Optimum sowing depth must be used to ensure that the germinating seedling penetrates the soil surface before they exhaust their nutrient or energy reserves. Coming to identification of QPM version of seeds. This is a simple technique and this is a must technique in order to identify and differentiate the QPM seeds from non-QPM seed. Though it is a practical issue, I kept this slide in the end. Here there are two techniques to identify the QPM seeds. One is the manual method by using light table, then with the help of markers, and the another issue is with the help of biochemical analysis. As I already discussed the biochemical analysis aspect, here I will talk about the light table. Even the method of using marker is also discussed before. Light table selection is necessary to identify kernels that may carry the O2 gene in the homozygous recessive state. It is preferable to use a light table rather than molecular markers or lab analysis, as it is quick and inexpensive, especially considering the hundreds or thousands of genotypes that may have to be screened from segregating population. The degree of modification is largely independent of protein quality, so light table cannot replace laboratory analysis at final stage to confirm and acceptable protein and tryptophan content. But as such, or for quick identification, this light table is good method of differentiation. In the previous slides, I discussed conventional and molecular techniques separately, but when we combine these two, it will be quite better. The breeding method by combining these two for conversion of non-QPM to QPM by backcrossing, non-QPM into QPM by pedigree method, and QPM into QPM by pedigree method. Components: a light non-QPM germplasm, good QPM donor, good testers for combining ability, and use of molecular marker. How it is used? First, identification of O2O2, that is done by qualitative determination, and hard endosperm. This was identified either by using light box or molecular markers. In the step 2, determining the lysine tryptophan protein quantities, that is quantitative determination, and the tools are biochemical laboratory tools. Coming to recently developed QPM varieties. The one variety is FQH38, the QPM version of Vivek Maize Hybrid 21. The new QPM hybrid contains more than 72% increase in tryptophan over Vivek Maize Hybrid 21. Anand QPM 1 developed from Anand Agriculture University. Here is a list of composites as well as the varieties which were developed for QPM version. First, Shakti, Ratan and Protina were the composites developed in 1970. These were having full season maturity, developed by AICRP. After that, Shakti 1 was a composite developed in 1997 by Indian Institute of Maize Research. Shaktiman 1, this was a three-way cross. In the previous slide I told that Shakti 1 is a three-way cross. Sorry, that is not. Shakti 1 is a composite. Shaktiman 1 is a three-way cross that was released in 2001. Maturity group is full season, developed by Dholi. Shaktiman 2 is a single cross developed in 2004. HQPM that is also a single cross. Now the recent versions of QPM are all single cross hybrids. Vivek QPM 9 was a cross between VQL 1 into VQL 2, released in 2008. This is extra early, developed by Almora. Coming to the protein, grain content and tryptophan and lysine content in the different hybrids or varieties developed. First one is Shaktiman 1. It has protein content in grain 9.6, tryptophan 1.01, Shaktiman 2 9.3 and tryptophan content 1.04. HQPM, it has 9.4 protein and 0.94 tryptophan percent, and Shaktiman 3 and 4, these are having around 10 grain protein and around 0.7 to 0.9 tryptophan. HQPM series have 9.8 protein and 0.7 tryptophan. Vivek QPM 9 has protein content of 8.46 and tryptophan 0.83. Coming to some of the stalwarts who worked for the QPM improvement. The two scientists, one is Vassal from India and Villegas from Mexico, bagged 2000 food prize. They contributed for the development of different QPM lines. High quality protein maize. There are 4 hybrids which are improved for quality as well as different micronutrients. First one is Pusa HM4 improved. This is recommended for northwestern plain zone, Punjab, Haryana, Delhi, Uttarakhand, UP western region. Characters are 0.91% tryptophan, 3.62% tryptophan, average grain yield is 6.4 tons per hectare and potential yield is 8.6 tons per hectare. Duration is 87 days for 75% dry husk, against the normal lysine content of 1.5 to 2% and 0.3 to 0.4% tryptophan in normal maize. Next is Pusa HM8 improved. This is recommended for peninsular zone, includes Maharashtra, Karnataka, Andhra Pradesh, Telangana and Tamil Nadu. Characters: contains tryptophan 1.06, lysine 4.18, average grain yield is 6.2 tons per hectare, potential yield is 9.2 tons per hectare and duration is 95 days. The third one is Pusa HM9 improved. This is recommended for northeastern plain zone, including Bihar, Jharkhand, Orissa, Uttar Pradesh eastern region and West Bengal. It contains tryptophan 0.68%, lysine 2.97% and average yield of 5.2 tons per hectare and potential yield 7.4 tons per hectare with a duration 89 days. Pusa Vivek QPM 9 improved it is a country's first provitamin A rich maize. High provitamin A content of 8.15 ppm, lysine 2.67% and tryptophan 0.74 as compared to 1 to 2 ppm provitamin A, 1.5 to 2% lysine and 0.3 to 0.4% tryptophan content in popular hybrids. The grain yield is 56 quintals per hectare or 5.6 tons per hectare in northern hill zone and 5.9 tons per hectare in peninsular zone. Maturity is 93 days in northern hill zone and peninsular zone is 83 days. Adaptation is for Kharif season in Jammu and Kashmir, Himachal Pradesh, Uttarakhand, hilly region, northeastern states Maharashtra, Karnataka, Andhra Pradesh, Telangana and Tamil Nadu. This was developed by ICR IARI New Delhi. Coming to the recommendation to adopt QPM in different countries. Continuous supply of QPM grains for the industry needs to be ensured through effective backward linkage and contract farming to ensure sustainable supply of QPM. Better demonstration, promotion, also awareness creation of stakeholders on QPM using proper channels to use it as food and feed. To harness full potential of QPM, there is an urgent need to sensitize the food processing and value addition industry in developing countries on nutritional benefits of QPM so as to generate and deploy QPM based value addition food products in both rural and urban markets. The potential of QPM, especially yellow QPM, should be promoted so as to strengthening the maize poultry value chain and properly utilize the sector. Further research on cost benefit ratio of QPM to determine value gained in terms of kg of meat and number of eggs, and also the quality of products by using QPM over conventional maize is required at each production setting. Incentives should be available like premium price for QPM producers and value addition over normal maize grains. It is equally important to involve private players for seed production and link the industry with farmers so that the latter get assured premium for their QPM produce. Hope you liked this video. I request you to subscribe my channel. Thank you.